Miller. Let's answer this question, number 17. The sum of the first three terms of a geometric series is 14. So when we add the first three terms of a geometric series, we will get 14. And the product of the first three terms of this series is 64. So we're given two statements there. I will focus on the first statement. Now, when we talk about a geometric series, which is a sum of a geometric sequence in essence, which is called a series, we normally use this formula. Sn is equals to A, open brackets, r to the exponent of n minus 1, close brackets. In the denominator, we'll have r minus 1. Where r represents a common ratio, Sn represents a sum. Okay, in this case, we are adding three terms, meaning that n will be 3. Sn is equals to 14, n is equal to 3. We don't have A, we don't have R. Where there is Sn, we will substitute 14, and where there is n, we will substitute 3. And that's what we will have. On the right-hand side in the numerator, you have A, open bracket, r cubed minus 1. We normally call that the difference of two cubes. You did that in grade 10. To simplify the fraction on the right-hand side, I will simplify the numerator first by using the rules of factorizing difference of two cubes. The first bracket will have r minus 1. The second bracket will have the first term in the first bracket squared. The middle term will be the product of the first term in the first bracket and the second term in the first bracket. And then you change the sign. What do I mean by that? In the first bracket, I will have r minus 1. Take the first term, which is r, multiplied by minus 1, which is minus 1. You will get minus r. Change the sign, and that will become plus r, which will be the middle term in the second bracket. The last term in the second bracket will just be the second term in the first bracket, and you square it. So negative 1 squared will give you positive 1. That's what I meant. By factorizing the numerator, the binomial in the numerator is exactly the same as the binomial in the denominator, and there's only multiplication in the numerator. They're not separated by any addition or subtraction. There's only multiplication, and that allows me to cross them out. Common factors, you will simply cross them out. R minus 1, you will cross it out with r minus 1. You will be left with 14 is equals to A in brackets. It's r squared plus r plus 1. Make that your first equation. That's all I can do with the first statement. So I'm done with the first statement. Done with this. I'm done with this. So I'm crossing it out. Let's read the second statement. It says the product of the first three terms of this series is 64. The product means you are multiplying. But what are we multiplying? I will first try to find these first three terms by using the general term for a geometric sequence. I will first substitute 1 where there is n, and that will give me the first term. So term 1 will be equal to AR, where there is n, you substitute 1, minus 1. You'll end up having AR to the exponent of 0. And anything to the exponent of 0 is 1. That is why term 1 will just be 1. What is going to be term 2? You just substitute 2 where there is n. Term 2 will be equal to AR to the exponent of 2 minus 1. 2 minus 1 will just be 1, so term 2 will be AR. Term 3 will be AR squared. These are the first three terms. They said I must find the product, meaning that I need to multiply those first three terms, which is I have to multiply it with AR and multiply it with AR squared, and that will give me a product of 64. That's what a product is. It is the answer that you get when you multiply. Is the result of multiplication. Now, when you multiply same terms, you remember that you simply add the exponent and you represent that term as a single base. So when you multiply, the base in the first factor is A. In the second factor, we have AR. In the third factor, we have AR squared. So it's A. A times A times A will give us A cubed. Because when the bases are the same, you add the exponent. This one plus this one plus that one will give us a base of A to the exponent of 3. What about the R's? This one, which is the exponent of the first R, I'm going to add it with the exponent of the second R, which is this 2. And that will give me 3. So I'll have a base of 3. I'll have the base of R to the exponent of 3, which is equals to 64. Now, the problem is I don't want those exponents of 3, and I've got factors, so all I can do now is simply cube root both sides. And when I cube root both sides, I'll end up having AR is equal to 4. You did that in grade 8. Remember when you were prime factorizing? We're going back to that. That's all you're doing here. Between A and R, which one do you want to make the subject of this equation? You did that in grade 10. Making a variable the subject of the equation means you isolate that variable. It's absolutely up to you. Because I'm calculating R for 17.1, they asked me to determine the common ratio. I will make A the subject of the formula, and I will name this equation 2. You'll go back to equation 1, and where there is A, you will substitute that 4 over R. Multiply that 4 over R by distributing it into the brackets. The first term will be 4R, the second term will be 4, and the last term will be 4 divided by R. Go back to your basics, grade 8, 9, 10, 11. You'll understand how I got those. I don't like working with fractions, and by now you should have mastered how to work with equations. You don't want your variable to be in the denominator, and you don't want to work with fractions. So get rid of fractions. How do I get rid of fractions here? I am going to multiply each and every term by R. Take 14 divided by R. Take 4R, times it by R. Take the 4 and times it by R. And the last one, take 4 all over R and times it by R. You will end up having 14R is equals to 4R squared plus 4R plus 4. Write it in standard form because this is a quadratic equation. I will take 14R to the right-hand side and make sure I have 0 on the left-hand side. I want one side to be equal to 0. And then I'm going to factorize the right-hand side. This is a complex trinomial, but I don't think it's complex because the last term is positive. It's your choice. Someone might say, oops, I've got a common factor, so let's divide by that common factor, which is 2. So you'll end up having 2r squared minus 5r plus 2, and that one will be easy to factorize. The last term is positive, so we know that both brackets will take the sum of the middle term. Then find factors of 4r squared, then the factors of the last term, which is 4. When you factorize, make sure that when you multiply the inner and you multiply the outer and add them up, their sum will give you the middle term, which is minus 10. Please check my videos on factorization if that confuses you. And I chose my factors wisely. In the first term, in the first bracket, I'll have 4r minus 2. In the second bracket, I'll have r minus 2. Because I've got 0 on the right-hand side, and this, guys, you have to make sure that to apply what I'm going to apply now, you need to make sure that the product is 0. You'll realize that on the right-hand side, I've got 0. If there's any number on the right-hand side, you cannot take each factor and equate it to that number on the right-hand side. I'm warning you, do not do that. Here I'm going to take each factor and equate it to 0. Because the product is 0, one of these two factors have to be 0. The factors are simply, in this case, the binomial, which is 4r minus 2. That is the first factor. The second factor will be the binomial, which is r minus 2. One of these have to be 0 because my product is equals to 0. So I'm going to take each of those and equate it to 0. I will end up having 4r minus 2 is equals to 0, or r minus 2 is equals to 0. It will not work unless on one side you've got 0. I have people when they have 4 there, or let me say 6, they'll normally say 4r minus 2 is equals to 6, or 4r minus 2 is equals to 6. It will not work. It only works if on the other side you've got 0. I repeated this in the previous video, and I'm hoping by now you're getting it. Now, when you solve for r in that first equation, which is a simple linear equation, you'll have 4r minus 2, you isolate 2, and then you divide by 4. You'll end up having r is equals to 1 over 2, and the next one will be r is equals to 2. I'm missing a, so I'm going to take each of these and substitute it into equation 1. Remember in equation 2, remember in equation 2, I said a is equals to 4 divided by r, so I'm simply substitute the first r in this case was 2. Well, I substituted the second r, and I substituted the first r again where there is r, which is 1 over 2. Simplifying the first equation where a is equals to 4 over 2, that will give you 2. The second equation where we have a is equals to 4 divided by 1 over 2, that will simply give you 8. So those are the two values. If r is 2, a will be 2. If r is half, a will be 8. Now, I'm done. I found my values of r, but now you will note that I'm now on 17.2, which asked me to show that there are two different series that satisfy the above equation. Remember the above equation said when you add the first 3 terms, you need to get 14, and when you multiply those first 3 terms, you need to get 64. Let's see if this is true. I will start with a, which is 2. R obviously will be 2 when a is equals to 2. I will simply multiply a with 2, it'll give me 4. 4 times 2, that will give me 8. Those are the first 3 terms that I've got when a is equal to 2. Add them. 2 plus 4 plus 8, does it give you 40? Oh, yeah, it does. What if we multiply them? Do they give you 64? Well, yes, they do. All right. What if A is 8 and we have a common ratio of a half? So if the first term is 8, the second term will be 4. And for me to get the third term, I'll take the second term times it by 1 all over 2. That will give me 2. If I add those three terms, will they give me 14? Oh, yes, they do. When I multiply them, will they give me 64? Oh, yes, they do. And realize this is a commutative property that you used to um, do in grade 8. And to find the sum, that is the formula that I think it was Garch that actually used that method to find the formula for a series, any type of series, and that is the formula he actually used, okay, which simply says that when you add numbers, rearranging them in ascending order, you will get the same sum as when you add them, rearranging them in descending order. The same numbers, they will simply give you the same sum, and that's how the sum formula for an arithmetic series was derived. And I think he solved that in a minute when the teacher was trying to make students busy because he was busy with something and he wanted to finish that, and Gars gave him the answer in a minute, if I'm not mistaken. Okay. I don't remember the story. I remember doing it in grade in my first year at varsity. All right. If you need any extra lessons, please feel free to contact everyone there. Under maths only, you'll have those three wonderful ladies. And under accounting, it's me, and we have Mrs. Kuchinga, who offers accounting lessons online via Zoom or Microsoft Teams. And if you're in Cape Town, you can arrange with her to have one-on-one lessons. Right. With me, I'm only available on Zoom unless you reside in Mayerton or you reside in Springs. All right. Let me just give you some work. I jumped a couple of exercises. The first one that I jumped was 11. Please try that. Try 12, 13, 14, 15, and the last one will be 16. To view them, remember that you just go back and pause the video, do it, and we'll do this in parts in the next videos. Also,